Okay, let's go here. You're actually going to do a lab where you guys make a saturated solution. So if you had like a sore throat and you were going to gargle with salt water and you were making it on your own, and let's say you added a little bit of salt and it all dissolved and there wasn't any undissolved solid left. When the solute completely dissolves, then that would be an unsaturated solution, okay? If you keep adding salt and you get to a point where you've dissolved a ton of salt and a little bit is undissolved and you can visibly see it with the naked eye, that would be a saturated solution. So this means no more solid will dissolve, and there must be undissolved solid present in the solution that you can visibly see, okay? Then a supersaturated solution means you heated it up to really high temperature, which means you can dissolve more salt than you typically would, and then you left it alone. You let it cool to room temperature without disturbing it, which means it's super unstable because you've got all of this salt dissolved in it that there wouldn't normally be. So there's more dissolved salt than there would normally be. It is very unstable. If you so much as add one more salt crystal to it, once it is at room temperature, the entire thing will recrystallize right before your eyes. Okay, so generally speaking, just to give you an idea, if I've got 3 test tubes and I'm comparing these different types of solutions, unsaturated, it's just going to look like this. Like it's all going to be dissolved. Like you won't see anything. Okay, saturated, you're going to see a few crystals undissolved in it. Okay, supersaturated, if you take a seed crystal, that's what this is called. So that just means you take one little tiny crystal and you drop it in there, okay? This will start to look like ice. You'll be like, is that ice? What just happened? And it just literally recrystallizes right before you, okay? Okay, now, let's take a look at the table that's on the next page in the 7.1 activity, because you're often asked to interpret tables like this, and I just want to make sure you guys understand what it means. So, on this next page, they show you the solubility of various salts in water. A couple things you want to pay attention to. Temperature is on the x-axis in degrees Celsius, and then they give you the solubility of the various salts on the y-axis. But pay attention to how many grams of salt are dissolved in grams of water. Sometimes they will change the grams of water that it's dissolved in. They might make it 200 grams, which means if we were asked to interpret that using this graph, you would have to double the grams that are dissolved. So let me show you. Generally speaking, as the temperature increases, do you see how most of these curves are increasing a little bit? That means the solubility of salt will increase with increasing temperature, generally speaking. Obviously, it doesn't for this cerium sulfate, okay? If I'm at 20 degrees Celsius and I want to know how much sodium chloride is going to be dissolved, then I would go up to the sodium chloride line, follow it over to the axis. It looks like somewhere around 35 grams in 100 grams of water. Okay, if I said how much will dissolve in 200 grams of water, you would double that and you would get 70 grams. Easy enough? Okay. The other thing I want to make sure you understand is that if I was at 20 degrees Celsius and I had dissolved 10 grams of sodium chloride, do you see how I'm underneath that NaCl line? So that means that we are an unsaturated solution. So anything under the line at that temp would be unsaturated. If I fell on the line, if I dissolved 35 grams, then I would be saturated. If I'm above the line, if I've somehow miraculously dissolved 50 grams and I was at 20, then I would be supersaturated. Easy? Okay. Let me see if there's any questions here that are relevant. I think we've got it all. We're good. Okay. This